So, hello everyone, and um, I'm very happy to be here today. Very excited to give my talk. I hope you are not too tired up to this moment. Let's have some fun. My talk is about building an AI chat assistant with Amazon Bedrock agent. But first, let's think about information we're dealing with. Uh, for me, it was funny to discover that the first SMS message was sent back then in 1992. By the way, it was the year when I was born, and it is funny to think that I am as old as SMS message. But now, according to different calculations, we have like 23 to 27 billion texts sent every day in the world. So you can imagine how the amount of information just increases over the time. And here I'm talking about SMS only. I'm not talking about emails, your social media, your messengers. Yeah, so and we are dealing with a big amount of information. And people are started to think, how can we automate? How can we deal with this amount of data and information going through us? And maybe we can use AI to help us with it. Yep, my name is Darya, and I work as a data scientist at SLB. And I work with machine learning and recently with generative AI, large language models. I'm an AWS community builder. Also a new Amazon authorized instructor, and I'm 4 times AWS certified. Hopefully I will increase this number this year. And this is my picture from my latest trip to Legoland, Germany. And yeah, let's talk about Bedrock. How many of you have heard about Amazon Bedrock? Yeah, pretty much everyone have heard about Bedrock. As you may already know, this is a service as a ground of foundational models. What is foundation model? It's a big model trained on a vast amount of data with like a huge amount of GPU trained over like the big amount of time. And the Bedrock service is fully managed, and it gives us an access to vast choice of high-performance models. When I counted last time, it was 28 models available there, and you can access them via single API. And there are like very famous models, like recent state-of-the-art models like Llama or Mistral or Stability AI models. And you can there experiment, evaluate your experiments. You can customize these models, fine-tune them, and yeah, just you have the single service for it. Last year, during the reInvent, new feature was introduced, which is called Bedrock Agents, and this is something I got very excited about it. Yeah, because I worked with Hugging Face agent, and yeah, I just excited about the concept, and I will explain you why. But first, let's think about what is an AI agent. So AI agent is an application powered by a large language model with a predefined system prompt. So it takes a role to do the orchestration and a correct tool or correct function selection. So it can understand what do you want from it, and it can understand what to do, no matter that the task can be pretty complex. But how does it work? How can it understand? So it uses a reasoning technique called REACT. REACT is short from reasoning in action. So when it receives user input, it starts to think it starts to think about what should I do and how can I break this task down to several steps. So it started to producing some thoughts, then doing some action, then observing the result, and then they have some kind of output, and this output becomes an input for the next step. And steps are chaining up together until the point that the final task is executed. If you think about it, it's pretty similar how we humans would deal with tasks. For example, if I ask someone of you to find out information about AWS Community Day Nordics this year, you would probably Google it, you will find a website, you will read some information, you will summarize it and provide it back to me. So it is similar what agent would do. So this gives us an ability to use agent as smart assistants. And I have here a couple of examples, whether from blog post, whether from AWS official workshop. So the first example up there, like left, it is, it was used actually in a blog post introducing the agent, and the use case that the agent can be used as an insurance assistant, and it can send a reminder to all policyholders with open claims and pending paperwork. So it had to connect to the database, figure out what is pending, what claims are open, and where should it send all the information. Example in the middle is taken from an official AWS workshop where you can build an agent which will be a solution architect agent. And under the hood, it is using information like knowledge from a well-architected framework. And by querying this framework, it is able to answer questions like how to design a secure VPC. And the last example is just to show that tools or actions can be very different. You can even like web scrub some URL and tell what's inside, what's on the like Pikachu picture. So use cases can be different. So I decided to get my hands a little bit dirty on it, to try to build on my own AWS account a chat assistant agent. It is built on Telegram chat. And I was talking about system prompt when I was talking about agent. So system prompt is the information you are given to agent so it can better understand its role. So, and it is added each time you are given input, you're asking your agent to do something. So it's kind of empowering agent and help it to better fulfill its role. And I ask to pull messages from a Telegram chat, to summarize them if I ask to translate them into English if they're not in English, and if I ask a specific question based on the messages pulled, it should provide me an answer. And here you can see the architecture. So you can see the Bedrock agent, which is doing all the orchestration and reasoning. And we have a Lambda is a toolbox. So agent can call Lambda and can select a correct tool in order to fulfill different tasks. So for pulling messages from the chat, it actually uses DynamoDB table to be able to retrieve the chat ID. Because as a human, I would probably ask to pull a message by a chat name, not a chat ID. So to be able to have this reference to chat ID, it is using like DynamoDB table and Telegram API. And also for summarizing, it using Bedrock again, but it's using Titan model to do a summarization. And for translation, it is using Amazon Translate. And to be able to understand the language, it is using a Comprehend. And we have here a 3. And I will talk about this in a moment. Why do we need a 3? And yeah, when I will be showing steps on how to build an agent. Yes, and I already partially talked about that, but the functionality of this agent is to pull messages from a specific chat, summarize these messages, or like translate messages, um, and answer my specific question based on the messages. And here are just some simple steps. How can you build an agent by yourself? So first, to set up the scene, like a prerequisite, you need to have a Telegram bot and update the token in order to connect to Telegram via API, and to store chat IDs and chat names. To do this one-to-one match, I created a DynamoDB table, and I don't even need to specify the full correct name of a Telegram chat. I can do something like fuzzy search and finding the closest chat name to what I gave to agent. As a toolbox, I created a Lambda function, and it contains several like Python functions, code written in Python, each for the specific action. So one function is pulling messages, another one is I'm talking about Python function. So all these functions are stored in Lambda function. So one function is pulling messages, one is summarizing messages, one is translating, and one is like answering a question based on a user-specific question. And to be able to create an agent, you just need to go to Bedrock console, choose the agent from a navigation pane, and then click on Create Agent. And here, by the way, I'm showing you the current setup on how you can create an agent, because like up to last month it was doing a little bit different, but now we have a kind of different setup with an agent builder capability, and I'm showing you this new version of creation. So in order to create an agent, you just need to provide an agent name, and that's it. You click create and the agent is created. But yeah, it can't do anything much, because you haven't empowered the agent. Next, you access Agent Builder and you can modify some settings. For example, you can opt to use an existing service role, but in most cases it is not needed, because a default service role which is created is sufficient to communicate to Lambda and to communicate to S3. Also, for the model, currently only Claude family is available there, but you can choose between Claude 1, Claude version 2 models, and Claude 3, Haiku, and Sonnet models. So for this use case, I choose Haiku. You can experiment with different models there, and Haiku is the cheapest version. And then you provide these instructions to the agent, so this general role empowering prompt, and you can also specify if agent can prompt for user input, or whether it's allowed to prompt more information from a user. Then we have action groups, and this is where you connect your agent with tools and empowering your agent to be able to do different kind of actions. So to create an action group, you need to provide a group name. Description is optional. And also, this is also something new that was introduced last month. You can choose action group type. And here, like previously, there was only one option available by defining an API schema. And this API schema is it's a document JSON file with the description of your APIs. So it serves like a list on instruction of an agent, so it can understand what kind of APIs it can trigger. But now you don't even need to provide this file in S3. But if you want to, you can. You can define it via inline schema editor, which is handy because you can modify it and see how the for example, you may want to add one more function to your agent, and you can do it quickly with the inline schema editor. And also, we have a new option to define your action group with function details, and it is something where you can avoid these JSON documents. If you don't want to do it, you just need to provide a name for your function. Description is optional, and provide parameters that are needed to fulfill this function. And you can of course view it as a JSON, and yeah, so you can avoid of writing this JSON stuff here. And also then you can choose what to do when it's invocation time. So previously, only one option was available, is to select an existing Lambda function. This is what agent should do, like previously, in order to fulfill your prompt. So it had to call a Lambda function. But now you can, for example, return control to user or to application in which your agent is embedded. And this may be useful when your workflow is going beyond Lambda, or where Lambda usage is not handy, or whether you can have like your agent implemented and tested quickly, so you can just type some input and proceed. And also here we have a new option to quick create a new Lambda function. If you choose this option, Lambda function will be created on your behalf in your account and will be connected to your agent. But yeah, of course, you can do later on some modifications to the Lambda code, because code provided inside this Lambda would be very simple, of course, but it is a way to save your time. And also, for this project, I didn't use it, but it is very, very powerful way to extend your agent just beyond the LLM, to add knowledge base. So knowledge base is a vectorized database, like documents, where agent can access and retrieve additional information. If you remember, when I showed you this well-architected powered agent, so they created a knowledge base based on a well-architected framework, and then agent was able to go there and to check some well-architected patterns and go back to the user. And yeah, when you create an agent, you may encounter some situations when the output is not as you expected, and there is an easy way to do like first debugging is to when an agent returns something, like here on the left, you can always see the trace. Trace is how the agent is thinking, and it mainly it will consist of pre-processing trace, orchestration and knowledge base phase, yes, and a post-processing trace. So during the pre-processing, agent decide in overall what to do with your input, what category your input is falling into. For example, it can be category D, which agent can assist you with your question, but it may also be category C, where agent can understand that it is unable to assist you with your question, or it can be category A when the input is malicious. And then you can check, like after checking pre-processing, you can check orchestration and knowledge base step. And this is where this chaining steps, like chain of thoughts, is happening. And you can see I asked here like get messages from the chat and summarize them. And I can see step by step what is going on, whether like pull messages function is being called, whether the summarizing function is called, and what the output, what is the reasoning behind each step. And post-processing is optional, but if you want to have your output manipulated or changed in some way, it's a correct place to do it. And also, though this is more like advanced option, but still you can alter the agent behavior by changing the orchestration templates, by overriding your own like behavior. You can also alter the model's parameters, like the orchestration LLM model's parameter there. And you can also alter the parser lambda function. So if you want your output to be parsed in a certain way, this is a place where you should look. And yeah, agents should be taken with a grain of salt because there are certain considerations and limitations to be aware of. And if you give an agent an access to API data, make sure that you're on a safe side. Yeah, security is something we should always remember about. Also, if your agent is interacting with the user, you should think about input validation and sanitization to prevent some injection attacks and malicious input. Also, you may want to control who access your agent and who can test it. Also validate how the agent is working, how it is performing, whether it is given what is expected. Yeah, do a lot of testing and auditing. And like agent itself limitation up to this point, only Claude family models are available as agents. In overall, I guess that they would be like sufficient for many use cases. But if you want to bring a specific model to be an agent, it's not possible at the moment. Also, there are only like 6 AWS regions where agents are available. Previously, it was 2, so good work. 6 is better than 2. And by its nature, agent can accept only text as input. Yeah, if you want a multi-model input, there is still a way to give it. For example, if you integrate your agent into some external application, and it can, for example, take audio as input and translate this audio to text and then give it to agent. But if you want to do it like straightly, it's not available at the moment. And also talking about my project, I wanted to do it, for example, with a Meta Messenger or WhatsApp Messenger, but Messenger's API are tough. Yeah, you cannot just pull messages from there. And also it worth mentioning that agent is not a silver bullet for all use cases. Yeah, when you have a just simple trigger response event, for example, if I wanted to have all my messages like pulling up in a certain time of day and summarized and given back to me, I don't need an agent. So I can just build something simple, some serverless-based architecture, and use models from Bedrock and have my messages returned. So agent is more about like more orchestration and deciding some more sophisticated way of workloads. And also, yeah, multi-model input is still a question. You can do customization, you can embed it in your application. But if you compare with the Hugging Face agent, yeah, where it is built on different transformers model and can accept any type of input you want. Yeah, so it is it is questionable if you need to use this multimodal input heavily. Yeah, and some conclusions. As we saw, Bedrock agents can do some understanding of your input. They can do reasoning, then can do orchestration, and that's give them an ability to assist you in different tasks. Building an agent is not something extremely difficult. It can be done easily in your console, and they are use case specific. Yeah, so you may want to consider heavily your use case. So I want to say thank you for listening, and this is a QR code of my example project which I built. If you don't want to start from scratch, you can check it out on GitHub. So it's just a personal project, but maybe you will find it valuable. And thank you. Any questions? Here we had a microphone somewhere, and it is okay.
Thank you for the presentation.
Thank you.
You spent some time thinking about the agent applications. Would you help our imagination going? Would you see any real life applications where this could be useful?
Real life applications, I think it depends heavily on the use case, on the industry. But I can imagine, for example, if you're working with documentation, like one use case I have in mind, for example, if you are doing a recruiting or HR like job, yeah, and you want to find candidates for a certain position, yeah, and you have a CVs, candidate profile CV stored somewhere as vectors, and you will have very different job inputs every time, and you can possibly like ask agent to analyze the position, analyze what they have in their storage of candidates, and maybe find a match. So this is what came to my mind.
And actually, you also were in my talk. That's actually what I'm looking into, using agents for autocorrection of transcriptions. Maybe doing the entity detection, then correcting this, correcting punctuations, and having this split into multiple steps. It's definitely something I will look out after your talk. So thanks for this.
Thank you. Any more questions? Okay, let's enjoy the coffee break. Thank you.